Here we go. All right, so day 2, 4.6. Today we're going to focus on the discriminant. All right, the discriminant. So I'm going to teach you guys what that is, how to find the value of the discriminant, and then how to kind of get meaning out of it, right? What it tells you about the solutions. So again, if you guys have your notes from the previous lesson, we're going to refer to examples from that. So that would be helpful to have. Okay. All right, so first off, let's write down the quadratic formula as a review. So on your notes, go ahead, write down the quadratic formula, and then I'll call on somebody to tell me what it is. All right, let me go to Zach. All right, Zach, what is the quadratic formula?
Negative b plus or minus the square root of b squared minus 4ac divided by 2a.
Perfect. And sounds like somebody is having a lot of fun over there. All right, good. This is your quadratic formula. This is how you solve for x in a quadratic equation. Now, today we are focusing on just the inside of the square root. This is what we call the discriminant. All right, b squared minus 4ac. This is the discriminant. Notice no square root, okay? Do not include the square root. It is just what is inside the square root. What's inside the square root? Okay, so our goal for these examples is to find the value of the discriminant. Then using that, describe the number and type of roots based off of that discriminant. Okay, so find the value of discriminant and then tell me how many and what type of roots to expect. All right, so example number 1. First thing we have to do is move everything to the left side, set the equation equal to 0. Very important first step. So I'm going to subtract the 16 and get this equation equal to 0. Now I see that A is 1, B is 6, and C is negative 16. Okay, to find the value of the discriminant, I have b squared minus 4ac, giving me 6 squared minus 4 times 1 times negative 16. All right, so that gets me 36 plus 64. And I get 100, and this is the value of my discriminant. Again, remember, we are not taking the square root of that. That value itself is the discriminant.
Miss, I'll have a question.
Yeah, question.
So we don't have to solve for the quadratic formula to get the discriminant?
No, the discriminant is just the b squared minus 4ac value.
Oh, okay.
Now, why that's useful is because just based off of the discriminant, it tells me what kind of solutions I can expect. So because this 100 is positive, and it's also a perfect square. All right, it's the square of 10. Because it's positive and it's a perfect square, I'm going to end up with 2 rational roots. All right, and that tells me the number and type of roots I should expect if I were to do the whole quadratic formula, Michael. I would expect 2 rational roots. And if you guys have your notes next to you from 4.6 day 1, look at number 1 on the back side, right? This is the exact same problem. Because inside the radical was 100, that discriminant was 100, when you simplified, you ended up with 2 nice rational roots, right? I think it ended up being, what was it?
2 and 8.
2 and 8. Awesome. Thank you. Ended up being 2 and 8. Oh, that actually might be a typo. I think it was 2 and negative 8. My bad. I think that was a typo. So it's 2 and negative 8. Yeah. Okay. So yeah, when you have a discriminant, positive and a perfect square, you get those 2 rational roots. Okay. All right. So this is almost kind of like a shortcut. If you just want to know what type of roots, you can just look at the discriminant. All right, let's try number 2. I'm going to have you guys help me out now. So help me find the discriminant. Michael, go ahead. Michael L, go ahead and help me find the discriminant for number 2.
All right, so we got, so it's already in the standard form.
Perfect,
So
good.
then we have negative 16 squared minus 4 times 1 and then times 64.
Good, awesome. And yeah, you can skip right to the step. All right, that's perfect. If you want, you could write out what A, B, and C are, if that helps you. But yeah, you definitely can skip that step if you want. Okay, 16 square, I believe, is 256. I only know that because I just did that in period 2. Okay, don't think I'm like a human calculator. I'm not. All right, minus 4 times 64 is also 256. Okay, so we end up with a discriminant of 0. Okay, if we get a discriminant of 0, this tells me that I'm going to have 1 rational root. 1 rational root if your discriminant is exactly 0. Okay, so if you look at number 3 from your previous notes, right, inside the root, you notice was 0. So when we simplified and we solved, we ended up with x is equal to 8. So we ended up with 1 rational root. All right, sweet. Let's go to number 3. Help me find the discriminant for this one, please. Let's go to Summer. All right, Summer, help me with number 3.
Okay, so you're going to plug in -5 into B, and then so it would be -5 squared minus 4 times 3 times 1.
Good. And go ahead and simplify.
So you'd get 25 minus 12. So do you get 13?
Perfect. Nicely done. All right, so with 13, I'm thinking this is positive and not a perfect square. Oh, sorry, there's an A there for square. All right, so I'm thinking, positive, not a perfect square. Well, this is going to end up with 2 irrational roots. So we're going to end up with 2 irrational roots. All right, so that's like example 5 in the notes from the day before. So we ended up with a rad 13, and because of that rad 13, it didn't simplify nicely, and we ended up with 5 plus or minus rad 13 over 6. So that's 2 irrational roots. All right, good job, Summer. And by the way, when you show work, the bubble, like the cloud, that's just like thought process. Okay, you don't actually have to write that down. It's just hopefully that's your thought process. The one in the boxes, those are your final answers. Okay, so make sure you have those down. Okay, let's go to our last one on this front page. Jaden, help me with number 4.
So A equals 3, B equals -5, and C equals 4.
Nice. Let me take a pause real quick. A lot of times people forget that negative on the 5, so great job, because if you did not get that negative, your whole answer would be off. So great job. Oh, I guess technically not in this one, but you guys know what I mean. Okay, Jaden, keep going.
So you plug it in the equation. So it's -5 to the power of 2 minus 4 times 3 times 4.
Perfect. Good. Go ahead, keep simplifying.
So then the -5 equals 25 minus 48.
Nice.
And then it equals -23.
Perfect. Nicely done, Jaden. All right, so that is our discriminant. I'll just call it capital D for discriminant. And thought process on this one is it's negative. It doesn't matter if it's a perfect, root, like -23 is not, but if it was -16, it is. It doesn't matter, actually. If it's negative, that's all that matters. And if it's negative, you get 2 complex roots, meaning there's going to be an imaginary part. All right, so we get 2 complex roots. So if you look back at number 7 from the previous notes, we had that rad -23, which when we simplify, pull out the I, and we end up with some complex roots, 2 complex roots. All right, good job, guys. So these 4 are the 4 situations you can have. All right, there's nothing outside of these 4 situations. So any questions on these? Okay, flip to the back and let me kind of generalize and organize this even more for you guys. Okay, so generally, when your discriminant, b squared minus 4ac, is positive, all right, and it's a perfect square, you're going to get 2 rational roots. Or if it's positive and it's not a perfect square, you're going to get 2 irrational roots. And just so you can kind of see it visually, what that means is your graph is going to hit the x-axis twice. This is your visual representation of the roots. Okay. If it's rational, it means those intersections will be nice numbers, right? Like -3, +1, for example. If they're 2 irrational roots, it just means that the intersections are not nice numbers. Okay. All right, so that's a kind of visual representation. Okay, next one. If your discriminant is exactly equal to 0, you're going to get 1 rational root. And visually, this can look like this on your graph, where it hits the x-axis once. By the way, all these parabolas can also face down, so it can definitely, like do that. Same thing, or it could do this, or it hits it once. So doesn't matter if it goes up or down. It's just how many times does it hit the x-axis. All right. And if it's negative, if your discriminant is negative, you're going to get 2 complex roots. And that actually just means that it doesn't hit the x-axis. So you might get something like this, or you might get something like that, where it just doesn't hit the x-axis. Okay. Any questions about how the discriminant kind of connects to what types of roots and how the graph would look like?